Then we get to single replacement. For a single replacement reaction, we're kind of doing both of what we did before. We have both a new compound that we're writing, Cb, and a new element that we're writing, A. Because A wasn't a compound and C was an element, but now they've switched places, hence the single replacement. So let's look at one of these. We've got zinc and hydrochloric acid. You've got a zinc atom being added to... Shh, honey. Shh, we're recording. You're on the internet now. Mama's not here. Mama went to work because she's an essential worker. So you've got zinc and hydrochloric acid. Excuse me, guys. The zinc is going to replace the hydrogen atom because zinc is a positive charge and hydrogen is also a positive charge because zinc cannot pair with hydrogen. They're both positive charges, right? So zinc can only pair with chlorine, which is a 1- charge. So I'm going to put the positive zinc with the negative chlorine. And you'll see that these two don't add up to 0 right away because 2 plus plus 1 minus does not equal 0. So I'll add another chlorine into the mix, and I'll put those two together. So giving me zinc chloride, which is ZnCl2. Then I'm going to add some hydrogen at the end, but hydrogen is a diatomic element. So I'm going to put a 2 on there. And I'm going to write ZnCl2 plus H2. And again, I'm not worried about balancing the reaction because if you do look at it, there is hydrogens and chlorines that aren't there. So a simple adding a coefficient will help balance that reaction and give me conservation of atoms as we're going through. Here's another example. I've got H2 and KBr. But for this one, I'm actually going to draw it for you. So we've got the hydrogen, which is a 1+ charge. 1+. And we've got K, which is a plus, and Br, which is a minus. So we know that the hydrogen is going to kick out the KBr. And what I'm going to end up with is H and Br together. And since it's a +1 and a -1, we can just set one atom on each one. Then the K will be left by itself, right? But K is not diatomic, so it's just one K there. Then I'm going to have to get crafty and write the formulas, which I have HBr and K. And then I'm going to have to balance. I'm going to need 2 HBrs, which will give me twice as many bromines. So I'm going to need to double the KBr, which will give me twice the minus Ks. So I'm going to need to double the potassium as well. And then I got a balanced reaction. Yes, I do have a balanced reaction, Marcella. So anyway, in this one, we've got kind of a backwards deal because this time sulfur is a 2- charge. Magnesium's a 2+, oxygen's a 2-. So this one, since this is a minus charge, it's going to kick out the oxygen. And I'll get Mg pairing with S. And then I'll have oxygen all by its lonesome. Then you might say, oh, hey, that's already balanced. But it's not really right because the oxygen is diatomic. There's a second oxygen with it. So my formulas will be MgS and O2. To balance that one, we'll throw 2 here, which will give me a 2 here, which will give me 2 here. Yay, done. Double replacement, probably the last one. It might look the most confusing, but really all that's happening, if I can show you with my pen here again, is that those two are switching. So C is now going to pair with B, and A is pairing with D. So here's an example. We've got calcium fluoride and silver nitrate. Now, when we double switch these, the silver and the calcium will switch places, or the fluorine and the nitrate will switch places, however you want to look at it. So the calcium, put that second instead of first, and the silver, put that first instead of second. And look at their charges. Do the same with the fluorine, pair it with silver this time, and you'll see that you'll get just AgF. And do the same with the nitrate, and you'll see, oh, hey, those don't add up to 0, hence why the nitrate has some parentheses around it, and I actually have two of them, not one of them. So then they add up to 0, and the calcium's paired with it, and I get calcium nitrate, which is CaNO3 and a couple of 2s help me balance this reaction right in front of the silvers. So if we're looking for pairs, here's your last example. We've got Mg is going to pair with CO3, so that's MgCO3, and Br is going to pair with H, but I'm going to put the H first. Okay, and I'm not going to keep the subscript with it. I only keep the subscripts with polyatomic ions like CO3 or NO3, basically with that O that goes forward. I'm going to look at the charges. Hydrogen's a plus, Br is a minus, so it's just HBr. When I balance it, I'm going to throw a 2 in front of there. Sulfur with magnesium, Mgs. Lithium with oxygen. Lithium is a plus charge. Oxygen's a 2 minus, so that Li will actually keep its 2 in this case. Nice. So you got Ag and nitrate. So you'll have Ag, that's an A, yikes, with NO3. Ag is a plus charge, NO3 is a minus charge. We'll add that to magnesium sulfate, which is MgSO4. Which is the other pair that we get out of there. And then here, K pairs with O. K is a +1 charge, so we'll put a K2O on there. And copper, which is a 2 charge, we'll get 2 fluorines with it. So you're basically pairing